Our next topic is going to be presented by Brian Vesely from Northern Lights. Brian was recently released from the Witness Protection Program, so we had a little difficulty getting his bio. So what I did is I called Christine Battles and I asked her to check him out. She found out all the dope on this guy. So what we've learned is that he is now the Vice President and General Manager of Northern Lights Incorporated, corporate headquarters in Seattle, Washington. He started with Valley Detroit Diesel, which was a distributor, in 1995 as a technician. Valley is the parent company of Northern Lights, and they're located in Los Angeles. He moved to the Pacific Northwest in 2004, managed the EMD medium speed business segment for Valley through 2015, when he was asked to join Northern Lights as the VP and General Manager. He brings 20-plus years of experience in the diesel engines and propulsion and generation from 5 kW up to 4.5 megawatts. He's also been an active boater over the last 20 years, still turns his own wrenches, both at work and at home. Brian Vesely. Where'd Brian go? There he is.
Thank you.
You're welcome.
I like it.
It was classified.
It was. Well, thanks for having me here, guys. This is my first year here, and I know we had a representative from our company here last year, Bob Center. How many of you were here last year and saw Bob's presentation? So, a few. At Northern Lights, we do everything from 5 kilowatts to 550 kilowatts. So we kind of run the gamut from small owner-operator type boats to classed larger yachts. I was made aware that probably most of the questions here were going to be dealing with the smaller boats, so I tried to get a pretty good balance of information to kind of touch all of the subjects, but keep it centric on the smaller boats. I did have one whole section, I'll kind of jump ahead and say that, on integration and smart boat systems that goes into J1939 and MEA 2000, but I think you guys have all been very well educated by the other presenters on that, so I might touch on it a little bit, but that'll probably leave us a little bit of time for question and answer after the fact. So we'll get started. My idea on the presentation here was to talk with you guys about some of the frequently asked questions, basically in general, about generator sets that I receive, our sales guys receive on a daily basis. You know, going on the basic understanding, you all know what a generator does from a basic standpoint, makes electricity so you can run all your AC powered appliances and stuff on the boat, charges the batteries and all that good stuff. So I'm not going to bore you with those details unless you drag me into it. So some of the first questions I would say that to me seem pertinent, and what I get a lot from yacht brokers is, got a customer buying a new boat or speccing a semi-custom boat, and they want to know what size generator they should get. You know, their old boat was a 40-footer and it had 8 kilowatts, and now they're going to 50, so they must need 50% more. Or their buddy told them they needed 25 kilowatts because they had this and that other equipment on the boat. And one of the things I would say that a lot of guys get into is, you say, okay, what's the total of all the loads on the boat, and I'm going to size my generator to handle every single thing on the boat that's always on. And that just doesn't happen. I mean, running all 3 burners on an electric range, wife blow drying her hair, and the microwave, and all the chiller plant running, and you're making ice, not really going to happen. So what we like to look at in the business is doing a actual load survey, and not just here's a total of the loads, but what types of loads are there? Are they motor loads? Are they resistive loads? Those things can determine what the actual starting requirements are on the generator set. So how many motors of what size? How many chillers of what size? All this kind of information, it might seem like we're trying to bore you guys with details, really important. What our goal is when we have a generator set on a boat that's properly applied is 50 to 80% of its rated power output is where we want to run it consistently. So, you know, we want to make the boat really nice and flexible for the user so he doesn't have to think, oh man, I got to turn this on and this on to try to bring the load on the generator up. We'd like him to be able to use the vessel, you know, flexibly the way they want to use it and have the generator sized right. So one of the big things I see coming from my standpoint as a technical guy and getting called to fix broken things is always number one is underloaded or underused generator set. A guy that leaves the boat at the dock doesn't start the generator set, and when he does, he puts 10% load on it. You know, that generator might have a 1,000-hour life being treated that way, whereas if you loaded it properly, ran it often, you could get 30,000 hours out of it. And you know, I make a buck selling a generator, but I really hate selling a guy a generator when he could have done himself a favor and made the equipment last longer. So when we do a load survey, a few of the basic things, volts and hertz, right? What voltage are you at? What's your frequency you're running at? You want to know your total connected load. One of the things I hear sometimes is, I got a single 50 or I got 250 amp shore powers, so I must need 100 amps. Yes and no. It depends on the boat. It depends on what equipment is on the boat. So it might be a good indicator of about the size of the generator. It might not. I always just ask people to look further, do their due diligence. Again, back into it, makeup of the connected load. Motors, resistive loads, it's really important to know what you have there. If you get all the data up front, the beauty of it is we can make a very accurate recommendation of what size generator set the boat actually needs, so there isn't any guesswork. Because the worst case I hear all the time is guys will call and say, I bought a 12K set for my little boat and I really end up running and I could have got away with an 8K. He spent more money up front and he's going to spend more money in the life of that generator to overbuy the generator. So just something to think about. I know they're often forgotten and abused. I was actually sitting here listening to the lecture on hull machinery in a happy engine room and thinking, I did anodes and cleaned the heat exchangers on my mains a few months ago. I'm going to have to go back and look at them, but it's been maybe 2 years since I looked at it on the generator. I'll probably only run the generator 2 hours in 2 years too. So, I'm as guilty as anybody on not running it hard enough and long enough, but, it's a fact. One of the other things I want to talk about, just kind of getting into engine technology, I'm going to say, the vast majority of older generators are out there mechanical injected. For us, anything under 40 kilowatts, we sell current US EPA certed with mechanical injection. I get a lot of questions. Hey, I want to buy a common rail engine because it runs cleaner. I got my main engine that I used to have to clean the transom off and get all the soot off, and I went to a common rail engine and it's so much cleaner. I want the same thing with my little generator engine. Well, yeah, they do run cleaner at light loads, but at the end of the day, really the generator is happiest at 50 to 80% load. And unlike the main engine, it's running at a constant speed. So just as a point of note, common rail engines, yeah, they're nice, they're good. They're also rather expensive fuel technology, and when you're talking, a $5,000 or a $10,000 generator set, to add another $5,000 worth of fuel injection equipment can get a little brutal. I mean, we're all here in a rational business. I can't sell something for 100% more than the competitor and think I'm going to be in business long. So there's always a balance and a trade-off. The big thing I like to tell people is, hey, if you spec the generator right, you load the generator right, you operate and maintain it properly, the fuel system, you're talking about an engine that's going to be burning a half a gallon an hour up to maybe a gallon an hour at the top end for some of these small generator sets, may not be worth the return on investment for buying that expensive injection technology. So just as a note, not trying to plug my product, but I see a lot of guys, it's like the guy that goes out and buys himself a nice SL65 AMG and never gets it above 30 miles an hour. Kind of a waste from a mechanical standpoint. So final note there, properly applied and maintained generator set can have an expected life in excess of 15,000 hours. And that's one of those things, again, kind of a feedback from the industry. I'll get brokers call me and say, hey, I got this boat, really clean, really nice. My own, prospective buyer's a little bit upset or worried because he's got 4,000 hours on the generators and he thinks he needs to replace them. Well, a generator set that's been maintained, operated properly, has service records, easily 15,000 hours in life cycle. I see them go even 5 and 6K sets from us and others, 25 and 30,000 hours. So it's not just something you look at and say, hey, it's timed out. Ask more questions, get some information. A lot of times I see perfectly good equipment pulled out for no good reason. So the next one I want to talk about is a question I get asked quite often, US EPA versus IMO. So any boat that's flagged in the United States is required to be compliant to US EPA emissions regulations, period, end of story. If you are flagged outside of the US, then depending on the size of the boat, you can have your local flag state rules, IMO rules, typically the most prevalent. So the big issue that I hear too, guys want to repower, they got a used generator they want to put in, no problem. They got an older boat, they want to put a new generator in. Well, any engine, Category 1, which is small engines, compression ignition, The first year for Tier 3 was 2009 based on the engine block manufacturer date. The most recent year for that same standard is 2014, and at the end I got an eye chart if any of you guys really want to be bored to death. It goes into displacement per cylinder, power output per cylinder. By and large, any engine built after 09 through 014 in that range is going to be a US EPA 3 engine. So if you are repowering your boat or putting a new generator set in the boat, doesn't matter if the boat was built in 58, 78, 98, 2018, US flagged must have the current US EPA emissions equipment installed when it is installed, unless you're buying a used or rebuilt engine. As a manufacturer, like all the other generator guys, we sell new stuff. So you would be buying a US EPA Tier 3 engine generator set from us. So IMO gets a little tricky, and the real trick is you have US EPA Tier 3, you have IMO Tier 3, you have IMO Tier 2. So do any of those three standards actually physically correspond to the other with regards to the emissions levels? No, they're similar, but they're not the same. So the real hierarchy is pretty simple. EPA 3 is about the same as IMO 2. EPA 3 is actually a little more strict than IMO 2. So if you have a boat that's US flagged with EPA equipment, they want to make it an IMO 2 boat and flag it outside of the US, no worries. When you start getting into larger yachts, and this is for the people here that get into the larger stuff, any vessel constructed after January 1st of 16 that exceeds 500 gross tons and has a diesel engine in excess of 130 mechanical kilowatts. So for us generator guys, that's about 115 electrical kilowatts on the generator, must be compliant to IMO 3 when the vessel's operating within North American ECAs, emissions compliance areas. Basically, part of the draw over from the Jones Act to help protect U.S. flagged boats that are operating within the U.S. waters that have to meet U.S. EPA Tier 3 and Tier 4 for the C2 and C3 engines to make sure the foreign vessels are at a commensurate emissions level. So I know it's a subject that could get really hairy and really dry, but the biggest thing is, I like to say, ask the engine supplier first. What I've ran into problems with is a guy will say, you know, meaning well, hey, no problem, you got a 200 kilowatt set in your nice old Benetti here, we can replace it with another one just like it, but it's an IMO boat, and the boat's over 500 tons, now you have to put after treatment device to get to that IMO 3 emissions level, because IMO 3 is actually pretty darn close to US EPA Tier 4. So that means diesel particulate filter, diesel oxidation catalyst, SCR, urea injection, you know, total complete replacement of the fuel system on the engine to go to a Miller cycle or EGR type system. So you're talking pretty intrusive stuff. So this is something that is, you know, kind of on the forefront. It just started, you know, in 16 for these IMO 3 rules, and I would say for us as a manufacturer, you know, at first it was some guys questioning, well, what should I do? What do I need to do? Maybe I don't do anything, and the big issue here is for us, you have boats that travel inside and outside of those emission control areas. So if the boat wants to operate that new generator inside those emission control areas and it meets a criteria, over 130 kilowatt mechanical, over 500 tons, have to be able to be compliant with IMO 3 emissions in those times. So I could give you a whole nother presentation on that, but I won't bore you all to death. Come and see us, ask any questions that you want, and I'm going to tell you, you know, all the big engine guys, CAT guys, Cummins guys, MTU, we're all conversant in this. This is something that's going to be coming more and more in the future, all these emissions rules. So another couple just kind of random thoughts that come to mind when I talk about this that are really salient points. When we as a manufacturer build an engine and certify the emissions to US EPA, the liability is upon us to comply to the emissions over the useful service life. That's how the EPA determines what size engine, how long it's going to last, how much emissions compliance we need to have. It's on us as a manufacturer, okay? When you're talking about an IMO boat with class, like you guys were talking earlier, the responsibility falls on the vessel operator. Okay, so part of the class compliance goes back to those engine questions. If you're doing your recurring machinery surveys, if you're doing just general maintenance and replacing the injectors, you as the operator, when I say you, but your customers as the operator on those IMO boats, have to make sure that they put in the compliant parts, part number to part number that match the IMO technical file called the EIAPP to ensure continuing compliance of the equipment. If they do not do that and the boat is out of compliance, the onus is on the operator. Whereas on a US EPA engine, the onus is on a manufacturer. So just something to think about. It as an added layer of complexity. When you get into larger boats, the crew really has to be on top of that information to maintain the IMO emissions compliance, as well as all of the other class compliances on those boats. So. And as I mentioned before, EPA 3 and IMO 3 are not the same thing, so please don't get confused. So I have another slide here to go over all of the communications bus questions that I get asked, and like I said, the other two guys really went over it pretty well, so I'm going to probably gloss through this real quick. We do, since we have mechanical engines, have the capability to make our engines J1939, basically as the guys were talking about earlier. All of these standards, just my own point on this is they all look like a bunch of numbers. You know, really all they are is standards to determine the physical and the communications layers of the networks. So I like to always think of it like it's a language, right? So you have a translator. If a guy speaks Japanese and another guy speaks French, you got to have a translator to get them to talk together. So all of these networks can work together, yeah, sometimes with lots of fidelity, sometimes in read-only mode, but they can all work together, and it kind of goes back to the same thing of choosing the right size generator. We want to provide the customer a situation where he has equipment that just works. He walks in, he pushes the button, and it does what he wants to do. And I think the real key for us on the technical side of the business is working with you all to really get a good understanding from your customer, because you guys are the communications link to us and the translator to us. Hey, my customer wants to be able to walk in and push one button and have the generator start and figure out what it needs to do. Okay. Or no, my customer doesn't mind going in the engine room and doing this and doing that, but he wants to have all the data at hand. Okay, there's a lot of flexibility, and you know, custom is expensive, so we could go everywhere between spending more money on integration than we did on the hard equipment, or we could be somewhere in the middle where there's light integration and light automation, and it's done for a very reasonable price. The big issue comes back to really accurate communications between all of us. In a manufacturer, we always like to partner with you guys that are directly in with the customers, because it makes all of our life easier. None of us here want to see you guys or us or the customer in a bad spot where they wanted this and they got this. Doesn't serve any of us well. So I like to say, you know, it's that old stitch in time takes 9. I don't sew, but it makes sense to me. So one of the things I found out just kind of working with some people is, again, asking all those questions. I was talking to the guys at Garmin the other day that their MFDs actually take J1939 natively. So, you know, it's a couple boat builders I've been dealing with, and I was telling me, yeah, you're going to have to buy an extra translator module. Well, come to find out, the MFD manufacturer says, no, you don't need one. Well, that saved that guy $1,500 on the boat build. Doesn't seem like a lot, but every little $1,500 change helps. So that's all I got to say on that. I did just put in some pictures in the slides here of all of the EPA regs with regards to Tier 3, and I won't quiz you on them, and then a sample of one of our application questionnaires that we would like people to use when they're looking to select a new generator for their boat. So I got a few minutes. If there's any questions, feel free.
Jeff has one up here. Shay?
I was thinking I stunned everybody into silence, so thank you for helping me.
Jeff, she's bringing a microphone to you. Hang on a second. Shay didn't realize she was going to have to jog today.
So my question relates to EPA certificates. Oftentimes we bring in boats from foreign flags to sell, and those EPA certificates are nowhere to be found. Some of the engine manufacturers will sell them to us.
Interesting.
At varying different prices. Is it a fair question to ask if Northern Lights would provide them free of cost?
If the engine is built to the correct standard, so it's built as a US EPA 3 engine, and let's say it was originally delivered on a boat in Holland, now the boat wants to be reflagged over here in the States, no problem, no cost to send you those certificates. I mean, we have them, we own them, it's basically as easy as printing it off and sending. We're a very small company and privately held, so I don't have to worry about corporate bureaucracy and that kind of stuff, so we get to make a pretty easy decision on that. So as long as the engine's already there, it really is immaterial.
Good answer.
Question in the back from Rich Marriage? Cindy? Yeah.
How you doing? Great presentation. We're working on a project which is we're taking out all the hydraulics, winches, valve thruster, and we're changing it over to electrical. And in conjunction with that, we're looking at using, we're changing out the gen sets and changing the load profile and thinking about using batteries as like a hybrid kind of thing. And I was thinking maybe this might be something interesting to touch on.
Yeah, so give me a kind of size of kilowatts you're looking at on this, or what kind of load range you're talking about. Took the mic away too quick.
I'm actually not up to speed on the electrical side of it, but I would just, it's a 95-foot research catamaran.
Okay, so, probably somewhere in the realm of a pair of 50 kilowatt generator sets. So, it was actually going to be one of my subjects and I nixed it. Talk about light hybridization. Okay, so there's a lot of ways. Hybrid would be bringing power from two sources onto a common or shared bus or load. So there is some companies out there that are working and building PM generator ends, which are DC, and then run that into a inverter-converter bridge with a battery in the middle, and with some battery management system software, are able to share the power output from the generator, from the stored energy in the batteries, and provide AC power on the bus. So that's a way to do it with PM and inverter-converter. The other way to do it is you can still do it with a synchronous machine and use a off the shelf for a lot of the smaller boats, inverter converter, like you'd get from, Xantrex or Magnum or Victron. And basically the converter becomes the controller, and it controls the generator when to start and stop based on the state of charge or, rate of discharge of the batteries and the desired state of discharge of the batteries. So yes, it is something we've talked about, been more involved in. I'm going to say the thing in that, just as a general overview, is when the generator, a synchronous machine, is on the bus as the prime mover in a weak system like that, it's really in control of the bus. When somebody is talking about doing hybridization like that, actually the generator becomes the slave. The battery controller / inverter converter bridge that puts the AC out to the bus becomes the master. So just puts us in a little different spot on the one line on the drawing, but yeah, definitely stuff that we've worked through a little bit. We did actually one hybrid project with the guys at BAE, but that thing was like a space shuttle when it didn't need to be that complex.
Interesting.
Yep.
Just one more comment. Yeah, the thought behind it was that the idea is that the vessel is going to be dynamically positioned, so the batteries will help keep the the power spikes down to a minimum.
Yeah, absolutely. I mean that's a big thing. Batteries are very good at high current loads very quickly, and whether they're lead acid or lithium polymer or nickel metal hydride. NIMH and LiPo batteries, actually to their own deficit, they will dump amps and kill themselves quite quickly. But it's a very efficient way if you have intermittent high loads or like high motor starts that you want to bridge the gap where, let's say, you would otherwise have to oversize and put a 150 kilowatt generator set. You could get away with a 50 kilowatt generator set and 500 watt hours of battery, because you're only going to be talking about milliseconds of these high loads. So it really can be a much more efficient way to control the bus, but again, it can also become much more complex, and complex equals cost. So that's the big balance that I see. A small boat builder that wants to have that kind of thing for a light pleasure craft, I'm going to say the battery technology for storage density really isn't there yet to get it to be very reliable. And just my other 2 cents on things. Everybody likes to make the comparison to hybrid cars. The one beautiful thing about hybrid cars is regenerative braking. That's where they make their efficiency, is turning kinetic energy back into electrical energy. So when's the last time anybody's pushed the brake pedal on their boat? That's a big problem. So anyway, do we have any more questions? I thought I saw another hand. Nope. Okay, well, thank you all.
Brian, thank you very much. Great presentation. Thank you so much. Appreciate it, buddy.